Wow, everyone, take a look around. This is awesome. No offense, Eric. No, huh? I don't think so. Really cool. Awesome. All right. Well, hello, everyone, and thank you for joining us for the next installment of our John and Mary Louise Riley Seminar Series. Before introducing our speaker, I would like to respectfully acknowledge the coastal Miwok, Southern Pomo, and Petwin peoples who continue to occupy, steward, defend, and govern the unceded lands where the Bodega Marine Laboratory and UC Davis presently reside as they've done for centuries unnumbered. Unfortunately, the colonial violence, forced removal, extraction, and erasure experienced by the first inhabitants of these lands are tactics that are not safely isolated to the annals of history. These tactics continue to be used to this day on people around the world and in our own communities. I implore us all to reflect deeply on the ways in which our systems, our institutions, the academy, and we as individuals are complicit in these actions, and to strengthen our commitments to peace through collective liberation. I am so pleased to introduce Dr. Caitlin Louder, who is currently a program manager at the Ocean Foundation, where she supports the Ocean Equity Initiative. She received her PhD in marine biology with a specialization in interdisciplinary environmental research from the Scripps Institution of Oceanography at UC San Diego. There, she researched the effects of ocean acidification and ocean warming on economically important crustaceans. Outside of the lab, Caitlin has worked to share how the ocean affects and is affected by climate change to both policymakers and the public. As a 2020 Knauss Marine Policy Fellow in NOAA Research's International Activities Office, Caitlin supported U.S. foreign policy objectives in science and technology, including preparations for the UN Decade of Ocean Science for Sustainable Development. To connect policymakers with ocean climate science, Dr. Louder attended COP21 in Paris and COP23 in Germany, where I was fortunate enough to co-lead a press conference with her on ocean acidification's relevance to UN Sustainable Development Goals. I can attest firsthand to Dr. Louder's deep dedication to conservation and sustainable use of ocean resources, and her commitment to engaging the next generation of scientists, innovators, and members of an ocean-aware society. Please join me in welcoming Dr. Louder.
Thank you so much for that welcome, Alyssa. I think it's incredibly important to make sure that ocean science is open to all, both internationally, but also domestic here in the US too. Today I'm going to be focusing more a little bit on that international side of ensuring ocean equity. And we'll be talking about some of the ways that our foundation is working with other sectors, governments, industry, and in many cases with academia as well. So thank you for joining us today. I'll start off by sharing that I'm a program manager at the Ocean Foundation, where I've been for the last 3 years or so. As Alyssa shared a little bit about my career, I'm happy to talk about career paths with others, but it was really my time at the NOAA Knauss Marine Policy Fellowship where I was able to understand what that vein looks like, where I'm not only doing the science myself, or no longer doing the science myself, I should say, but really enabling and amplifying research to ensure that ocean science is conducted in all the places that it should be around all of our ocean basins, along all of our coasts. So I've been at the Ocean Foundation for around 3 years now. It's a 501c3 nonprofit that's based in Washington, D.C. I myself am based remotely in San Diego. We're a community foundation, which means we are serving a community. Community foundations are typically place-based, so there's a Cisco Foundation, for example. Lots of major cities have them. But for us, our community is the ocean. And so our community is everyone that depends on the ocean. So lots of different partnerships and sectors through our organization. We do this work primarily through 4 core initiatives at the Ocean Foundation. The first is our Blue Resilience Initiative, which is heavily focused on conserving and restoring marine habitats. There's work in Cuba on coral restoration, work in Puerto Rico and Mexico on mangrove and seagrass restoration to ensure that those benefits are there for the future communities that are relying on them for coastal resilience and climate change benefits. Our newest initiative is called the Teach for the Ocean Foundation. It is largely centered around engaging marine educators and ensuring that they have the tools and support necessary to advance ocean literacy for students all across the US and internationally as well. I'm part of our Ocean Science Equity Initiative, which I'll share a little bit more about. But in short, we're helping to make sure that researchers and practitioners around the globe have the tools and technology and support that they need to study changing ocean conditions. And then lastly, we have a plastics initiative, which is focused on some of the policy work towards ensuring that we have a more sustainable life cycle of plastic. So they are heavily focused on the legally binding instrument that's in development for plastic pollution. So again, this is sort of where I sit. For the last year or so, we've had a team of 2. As of last month, we have a team of 3, and then starting next week, we'll have a team of 4. And together, all of us are really focused on ensuring that we can advance the ways that we can support ocean equity to support ocean observing. So historically, for our initiative, this has focused on ocean acidification or changing ocean chemistry. But over the last couple of years, we've sort of broadened it up, and now we're looking at observation in a couple different ways that I'll touch on here, in terms of eutrophication, weather and climate observations, all these sorts of themes where we can use our expertise in capacity building and capacity sharing to help make sure there's more research on our ocean going along around the globe. So we really came to this topic by research like this. So it's taking a look at where ocean science capacity is distributed around the globe. So papers are just one metric, of scientific outputs, but in this figure from the Intergovernmental Oceanographic Commission, each country is proportionally sized to the number of research papers that are coming out the lead author from that country. So you can see that the US is a little bit bloated, Europe is quite large, and then places or continents like Africa are largely non-existent except for that little chunk of South Africa there. So our goal is to ensure that we can enable researchers all around the globe to study the ocean in a meaningful way, and hopefully in a couple of years, ensure that a future iteration of this map looks a little bit more representative of the peoples that are in their own countries. And as I mentioned, ocean acidification has been an area that we've really focused on. So this is a fresh off the press map from the State of the Ocean report that just came out a week or 2 ago from the Intergovernmental Oceanographic Commission that's looking at the countries that are reporting to the Sustainable Development Goal 14.3.1, the goal of which is to ensure that there are representative pH sampling stations all around the globe. So every year, researchers can contribute data through their national focal point to this database that the Intergovernmental Oceanographic Commission compiles, and they take a look at where these sources of data are coming from. So in this latest map, with the latest bulk of data that they got this past January, just 35 countries are reporting. So it's fewer than 20% in the world that are monitoring ocean acidification. And as you can see from this map, many of these coastlines in these countries, there may only be like 1 or 2 places where this is being monitored. And so challenges like these are what we're trying to address to ensure that for some of these phenomena that are incredibly important across the ocean, we're getting those data from all different places so that we can accurately characterize the rate of change of these conditions, and importantly, so that researchers in their own communities can understand how fast these ocean conditions are changing and be able to contend with them in the future. So there's a couple different ways that our team works to advance equity in ocean science. We do that via capacity building, capacity development, capacity sharing, these sort of blanket terms for our work of building partnerships and working very closely to advance ocean science. Some of those ways include funding the local experts. So a lot of the time, our funds may be a pass-through to the researchers actually on the ground to provide support for them. Here in the US, we're very fortunate that we have funding sources from our government. We have many different agencies that we're probably pulling from and contributing back data that's helping us study our oceans. Many countries don't necessarily have that sort of governmental support. So when possible, we are providing that funding directly to allow the researchers to take on the kind of science that they are interested in doing. When we hire contractors or partnerships, for example, we're asking something back. We're making sure that we're paying them at local rates, either going to government bans for certain positions where these folks might be working at, or looking at international organizations that have offices in different places, and ensuring that we're compensating our partners for the time that they're doing, whether it's conducting the research or gathering more information on data gaps. We want to make sure that that's well recognized. I also work to what we call bridge the technical chasm. You don't know what you don't know, and for a lot of these researchers who are interested in studying different parts of ocean fields, they may not have the mentorship opportunities that those of us in an institution like this may benefit from, like the esteemed researchers who have been in the field for 10, 20 years and provide lots of tips and tricks. So we work on providing those sorts of expertise and mentorship to our partners, and oftentimes also supplying equipment or other sorts of technology that enables them to sort of get over this gap and begin research in a certain field to support that, again, that production of ocean science knowledge. And then we also aim to elevate underheard voices. That can take a couple different forms. For example, something that we've been working closely with the NOAA Oceanification Program and the Global Oceanification Observing Network is supporting their peer-to-peer scholarship program, which matches a peer in the field, like an expert researcher in oceanification, with their peer or their colleague who's in a country where they may not have access to that sort of mentorship. So since our partnership with them, we've been able to fund over 30 scholarships for these peers that support small, cohesive projects that enable these mentorship activities to take place and really launch the new researcher well into the field and have some outputs to begin with. In other cases, this means funding researchers from all over the globe to attend international fora like the United Nations Ocean Conference. We will invite them to speak on panels to really share perspectives from their part of the world and have that voice in these international negotiations or in these large fora where priorities for ocean science are being considered, to ensure that it reflects not just the North American, the European perspective, but really all over the coast. And in some places where maybe our partners aren't invited to speak, we will elevate the perspectives that we hear from them, bring up some of those key gaps. So even if they're not physically at the table, like, your voice is still heard through us. But the one thing I really want to focus on today is this aspect of bridging the technical chasm through a couple different projects that we have working on, which I'll showcase, and talk a little bit about how we are working with academics and opportunities for getting engaged with nonprofits if you're interested in those sorts of pieces of work. So starting off, we'll be talking about some of the kits of equipment that we share, the equipment that we send to researchers all over the globe for them to conduct their ocean science, talk about some supporting tools for conducting ocean science via videos and practical best practices, and then when it's not possible to have sort of off-the-shelf technology that meets the needs of some of our partners, a little bit of work we've been doing to develop those sorts of pieces of technology. So to start off with, one of the hallmarks of our program has been the GOA On-in-a-Box kit, short for the Global Oceanification Observing Network. It's a suite of equipment that's suitable to sample and measure total alkalinity and spectrophotometric pH to weather quality standards as defined by the Global Oceanification Observing Network. And again, it's been a hallmark of our program. We've been working on this since our initiation. Right now, it consists of over 90 unique pieces of technology, essentially everything a researcher needs to start an oceanification monitoring program in their country, except the electricity and the seawater. When we have funding to deploy kits, we have an open application process, typically in a certain region, and then competitively select our recipients. And so once that happens, we don't always send them just the same equipment. I work with them to customize their kits based on what they already have in the lab. Like, do they have a spectrophotometer already? Like, we could repurpose that for the spectrophotometric pH measurements. Do they have a water bath? Fabulous. If so, we'll provide the connections. So when they're doing their total alkalinity titration, they can have a temperature-controlled water bath. If not, we show them how to connect tubing to either side of a jacketed beaker to perform sort of the same fits. So it's a lot of back and forth with our recipients to find the kit that works for them. But in total, what's typically included are a couple of autonomous sensors. So the ICME pH sensor from Sunburst Sensors is a hallmark of the kit to enable continuous pH monitoring. We also include a CTD diver for CTD measurements. And then there's many components that are focused on bottle samples. The bottle sampling itself, including a water sampler and the nice borosilicate bottles for ocean acidification monitoring, and then the components to bring those samples back into the lab to measure them, including a spectrophotometer, all the accoutrement for that, and to allow them to produce the metacresol pH indicator dye as well, and then a whole component for the total alkalinity system, and of course, some lovely reference samples or reference materials that enable them to compare their measurements and get a sense of where they're landing in terms of quality. So just a snapshot of what this looks like. We're not only including the hardware, but also some bits of software on that end. So we have a laptop that's preloaded with Excel and a carbonate chemistry calculator, as well as some sensor-specific programs. The whole kit itself is around $26,000 right now. We were really hit hard by those COVID-era supply chain issues where the prices just really jacked up. So it's gotten a lot more expensive over the last couple of years. But if anyone is interested in taking a look at what's in the kit, you can either go to the GOA On website and navigate over to their tab for the GOA On Our Box kit, or this hyperlink should bring you to that. I maintain a spreadsheet where everything is hyperlinked back to the manufacturer with different options, most up-to-date pricing, some other options if something goes out of stock. And so this is a resource that we provide to the community. So if we're not providing a kit, other researchers can go and purchase it, or purchase specific components if they're interested in doing just one of those different measurements. It's built to be replaceable and repairable via a modular design. So users can swap out and troubleshoot different parts if there are any issues. An all-in-one Metrum titrator might be super nice. It's also quite expensive. And if that breaks, it's a little bit difficult to understand how to go in there and find replacement parts or even understand what's going on. So our total alkalinity system, for example, is sort of a mishmash of different pieces and components. But if the multimeter fails for some reason, researchers can actually go and test different parts and understand whether it's the preamplifier or one of the fuses. And speaking of that, we also include maintenance materials and spare parts with the kits. So that can include spare fuses for the multimeter, extra reagents, but also specialized tools like little screwdrivers to maintain the sensors. So we try to make sure that we're shipping something that is sustainable well into the future, because getting replacement parts in many of these locations where we're shipping kits is incredibly difficult and very expensive. So whereas we might take for granted, getting on Fisher Scientific, ordering something and seeing it in the lab like the next week or two can take months, and it can be incredibly costly to do so. So we try to give them everything they can to maintain it themselves. So I just want to highlight just some of our experts that have been really key for developing the Go On in a Box kit. My supervisor, program officer, Alexis Valori Orton, began working with some of the experts in the oceanification field a couple of years ago to figure out how to adapt some of those standard lab methodologies and practices into something that can be replicated in other labs that don't necessarily have those sorts of resources. So Dr. Christopher Sabine and Dr. Andrew Dixon were incredibly helpful in telling her, what components to order. Dr. Kim Curry has been incredible in terms of adapting a methodology for spectrophotometer for measuring pH in an easy way. And then we've really benefited from the expertise of Dr. Sophie Chu and Dr. Melissa Melendez to be able to troubleshoot along the years and ensure that whenever we're compiling and sending a kit, it's something that's up to date and functions properly. So incredibly grateful to our academic partners here. And I'm also always interested in getting feedback or talking to others too, so happy to chat about that if you have ideas. But to share a little bit more on what the Go On in a Box kit enables, the idea is that, again, researchers who obtain this kit can then have everything that they need to be able to contribute to our global understanding of ocean acidification by submitting data to the Sustainable Development Goal for ocean acidification. So we really ask that they're focused on that carbonate chemistry monitoring. But what's important is that the research plans are designed by the scientists. We provide some coaching on what's feasible, right? Like you have to put the ICME in a certain depth of water, so you shouldn't be looking to a field site that's 20 meters. Or collecting bottle samples and measuring them can be really time consuming in the lab. So perhaps you want to choose a couple of different sites where you can then stockpile the bottles and measure them every 6 months or so. We really talk through these options, but the ways that they're using the kit can vary, whether it's for that the chemistry side, whether it's a little bit more of a biological bent. We really allow them to sort of shape their own research goals in that way and own their own science and their data. The kit, though, could also be used for doing some biological activity monitoring, depending if they're deploying it in an area with more activity, like a coral reef environment or a kelp forest environment where they may be getting some more of those cyclical signals. The ICME pH sensor could help capture that. And then it could also be used, too, for doing some simple biological experiments, using the bottle samples and then measuring the conditions that they're creating back in the laboratory. So just to share where we've been so far, Over the last 7 years or so, we've been able to deploy 28 kits in 23 different countries. I'm compiling 6 of them right now and getting them off to a couple countries in the Pacific and then 4 in West Africa, so we're super close with those. With shipping, is probably totaling around $750,000 in investment. And you can see from this map here, we tend to have a regional focus depending on where the funding is coming from. We've been really grateful from the State Department, NOAA, Fisheries and Oceans Canada, and a couple other governments who have helped fund this work. But that has led to sort of these pockets of work in Latin America and the Caribbean, and a couple spots in Africa. As I mentioned, our salient work right now is in the Gulf of Guinea and West Africa, but we've also been able to return to the Pacific Islands a couple of times, and that's where the bulk of our equipment is right now. Many of our recipients are at universities. We also have a lot at governmental offices where they wear a lot of different hats. Our partners in Palau, for example, are doing eDNA, doing coral monitoring, they're doing some fisheries work, and then doing the oceanification on top of that. Our partners at the Samoa Met office are primarily tasked with monitoring incoming tsunamis, and so constantly keeping an eye on the smart cables and things for that. At the same time, they're doing carbonate chemistry. So we're trying to work with them and build in the monitoring that they want to do that complements their other areas too, and respecting that they have a lot going on, and we're trying to make it as simple as possible. So I just want to highlight one of our kit recipients that I've been working with really closely over the last couple of years, Dr. Lindon Havamana. He's one of our newest kit recipients in the Pacific Islands. He's based at the Solomon Islands National University, and his research interests are in studying tuna and the long-term drivers that are influencing those sorts of biological data. So we were really glad to welcome him and his colleague, Dr. Wycliffe Tupidi, to our most recent training in Fiji. And so now he received his kit a couple of months ago, and they're beginning to start to do these deployments in concert with some of their other field work. So I'm really excited to receive their first report in a couple of months. And I want to highlight that we aren't just shipping equipment and saying, go have fun with it. Whenever we do these sorts of regional projects, we make sure that we're inviting research to a hands-on training in their region to ensure to walk through some of the practices of the kit and how to best use it. And again, refine their research plans in concert with what's feasible with the kit. So our workshops have really grown in size and scope over the last couple of years. When we first started, they were really small, topical groups of scientists. Now we're happy to host really advanced trainings, in some cases international symposia. We're on the outskirts of these practical trainings. We're inviting policymakers, we're inviting people in industry, and really gathering these groups together to think about what it looks like to do monitoring in the context of their international priorities. We also bring in experts to our trainings. I have a research background in oceanification, but I don't actively do it anymore. So we like to bring in experts who do that. So see here Dr. Kim Curry at one of our trainings, Dr. Christopher Sabine over there. And so they're really leading the hands-on practices of working in the field, what it looks like to do the field sampling, and then in the laboratory doing those sample analyses throughout the course of a week. So again, if you are an oceanification researcher and are interested in learning more about this, come find me. I'm leading a training in Ghana next month with Dr. Sophie Chu, so it's probably a little late to get on that given the visa issues, but let me know and I'll keep you in mind for future opportunities. We could discuss what those trainings look like. Always happy to have researchers who are really excited to share their expertise and showcase what science looks like in other places. Great, so we've had a lot of success with this Go On in a Box for oceanification monitoring. We've heard from a number of partners interested in replicating this sort of approach for other parameters. And so one project that we've just begun with Fisheries and Oceans Canada is work to replicate the Go On in a Box kit for eutrophication and create a global eutrophication monitoring kit. This has a little bit of a different setup. It's all field components, so it's a little portable spectrophometer to measure nitrogen, silica, and phosphate, and then some sensors for dissolved oxygen. And so our role is really putting together those kits and shipping them out, but we've been working closely with Fisheries and Oceans Canada to select the kit recipients. We just talked about applications this week. Looks like we're going to have recipients in the Indo-Pacific, in the Caribbean, and then both on the Atlantic and the Indian Ocean side of the African continent. And the goal of this is quite similar. It's to make sure that researchers have the tools that are necessary for them to monitor their waters. A lot of the drivers that they're talking about in their applications are different. One researcher is interested in the guano coming off a small island. that they're working on. Others, of course, are concerned about land use practices, agricultural runoff, sewage runoff, and the implications for the management and the monitoring of that. So similar to our work with oceanification, we've established this kit at such a level that they'll be able to submit data to the Sustainable Development Goal for eutrophication, which is 14.1.1a, very technical. And all countries are supposed to be contributing these data to the Sustainable Development Goals, so helping them meet those commitments at the international level. And of course, we're creating sort of standardized practices to improve the development of mitigation strategies. Fisheries and Oceans Canada is really excited about working with the policymakers as well to ensure that the data from these scientists is going into the monitoring side, because they're a champion in the Commonwealth Blue Charter. And so they have sort of training and ideas for how to ensure that those pieces of science are getting translated up and actually turning into tangible pieces at the country level. All right, so I've talked a lot about equipment, and that's, again, one of the components that we send. We make sure that the researchers have the actual tools to do the kind of science that they want to do, but we also try to supplement that with perennial resources to enable them to conduct these measurements and meet international best standards. And so in 2019, a group of oceanification aficionados got together and began thinking about what it would look like to create a set of practical best practices or a cookbook for conducting ocean acidification research, primarily with a go-on-in-a-box kit, but something that could also be used more broadly by the community. So the goal is to create a resource, again, that's tailor-made and can help bolster these kit users over time, right? We invite them to the trainings, but again, they wear a lot of different hats, a lot of different specialties. We want to make sure they can reference back to something. And in many cases, researchers in these small islands, these small communities, have a lot of flow in and out. You know, students may have to go to a whole other country to pursue their graduate studies, and then we've lost a lot of the specialized knowledge that was gained through the training. So these practical best practices can help supplement that sort of knowledge over time. So currently, I took this project over in 2022, and we're getting super close to a version 1 of our practical best practices online. Right now, it includes 22 different documents across a couple different categories. We have some on general practices. So what to pack for the field, right? If you've never really spent much time going out in the field, or you have to transverse far, you might not know that you should have backups of zip ties or other sorts of pieces. So providing a checklist for that. Providing a template for collecting metadata in the field. You know, taking temperature and salinity is incredibly important for carbonate chemistry, so ensuring they're writing those down when they're collecting their samples. We also have a section on using the sensors in the go-on-in-a-box kit, not only just how to program it and relying really heavily on some of the manufacturer-supplied information, but frequently asked questions too, because a lot of these pieces break over time, and manufacturers often want to receive the instrument back instead of providing guidance on servicing it. So we've gathered some of our experts who are good at taking these things apart and provided some pictures and other pieces of guidance for actually doing that servicing. We have a large chunk of documents that are focused on taking the discrete samples, so actually how to take a water sample and then how to go through the total alkalinity and spectrophotometric measurements back in the laboratory. Really clear step-by-step processes. We don't assume that anything is inherently understood. Make sure that all the little bits and bobs are written out in those methodologies. And then we have a section on data management. So how to QA, QC your data, how to collate the sensor data with the water sample data, and then how to submit it to the Sustainable Development Goal database. Ensure that those data are getting out somewhere when the researcher feels comfortable enough to do it. So this is what a guide sort of looks like in practice. This one is for SpecPH. Of course, we link to the original best practice. In this case, it's the Guide to Best Practices led by Andrew Dixon in 2007. So we make sure that the researchers know where sort of like the golden, amazing, like full detailed resources in case they're interested in looking at that. But knowing that these best practices are often written for a laboratory that is well-resourced and is trying to obtain the highest quality data possible. Instead, we want to make sure that our guide is really focused on using the kit and getting to that weather quality data goal. And it's great if you can get higher quality data, but perhaps not necessarily useful for biological measurements or some of the other sort of monitoring that they're doing. We also like to include links to videos when possible. So We have a reference video for actually performing this measurement in the lab, so they can go and look at that. And we have captions in 4 different languages. So we link to that as well. So if English isn't their first language and they prefer to sort of watch rather than read, they can go ahead and take a look at those versions. In addition to just the methodology, we also talk about the QA/QC process for these data that come out of the methodology, and then link to some of the templates that we have. So in this case, when the spectrophotometer pops out with its readings, they can enter it into the source spreadsheet, and that will calculate their pH reading for them. So too many authors have been a part of this version 1 to fully put all their pictures on screen, but you can see that we have benefited from having a lot of different areas of expertise, researchers all over the globe in the Mediterranean, Europe, Pacific Islands, and then also some folks from the Intergovernmental Oceanographic Commission, the International Atomic Energy Agency's Oceanification International Coordination Center, and then some folks in the NOAA Oceanification Program, NIST, lots of areas of expertise here. And this is also my call. If you're an oceanification researcher and you're interested in learning more, we're working on a version 2. I gathered some of our co-authors together in Monaco in March, so hint, hint, sometimes you get to travel when you're engaged with this work, to sort of envision what our next set of best practices might look like. For this, we're filling in some of those key gaps on spectrophotometric pH, how to refine your practices if you want some higher quality data. But the hallmarks now are really focused on the biological side. So how do you, take this chemical data and really translate it into understanding biological impacts? How do those two things sort of mesh together, especially out in the environment, which is so complicated? We're also working on a decision tree. So researchers can take a look at this and think, these are my research goals. This is sort of like the question I want to answer. What do I actually need on the back end to make that happen? Or alternatively, I have these resources, right? I have these pieces of equipment in my lab. I have this technical capacity with the folks that I'm working with. What sort of questions can I answer? So we're working on this. We meet once a month. This is not the main job for anyone who's working on these, so it's a little bit of a slow process, but it's a time for us to come together every month and work through some of maybe the disagreements we have on the methodologies, or raise questions among each other. And it's an incredible group. I've really enjoyed working with these folks. So again, come find me if you're interested in that. But I just want to say, in general, for any of our expertise in this room, your field can benefit from your sources of knowledge. Don't discount the impact of taking a really quick video of a methodology in the lab that maybe you perfected, or you know some inside tips and tricks, and throwing that onto YouTube. It doesn't have to be anything fancy, as long as you get a good view of what the methodology looks like and talk through it. Maybe you can share it through certain networks within your field, if there's like a seagrass forum or eDNA, whatever it is. You can share it, and researchers online will find it, I promise you. We have our playlist of these 4 videos for using the Galron Box Kit online, and just in the last 2 years, we have over 2,000 views on these videos. And again, this is a very niche topic, but it's been a big boon to the community as we've learned. And then our cookbook authors sort of got together for a poster earlier this year and talked about some tips and tricks. So if you're interested in writing best practices, the Ocean Best Practices System, which is sort of a group online, collects and collates those. And so we think it's really important to describe tips and tricks, right? We've all benefited from mentors in the lab who've shared oh, don't do it this way. This way is a little bit more efficient or leads to better data. Or importantly, pitfalls, right? If you skip an important step, or when doing a total alkalinity titration, if some water splashes out, Alyssa has taught me about in graduate school, those are some things you want to pay attention to. And if you're not a carbonate chemist, you might not know that it's important. So writing down those little bits and pieces can really be a benefit to researchers. So even if you aren't traveling to far-flung places or have a large international network, just putting some of this stuff out online can really help benefit researchers all over the globe. And these aren't pieces that are found in methodologies, right? We don't write these little tips and tricks in there. It's sometimes hard to get the nuances that really make something work. And so this is one sort of way to put that out there. All right, and sort of one of the other things I want to touch on is our work on developing low-cost technology. We've been working on something called the PCO2to-Go for the last couple of years. It's in concert with Dr. Burke Hales, who you might know at Oregon State University, but we're working with him through his LLC, Decounalytics. Burke has been an incredible engineer, chemical engineer in the ocean acidification field. He's created the Berkolator, which is a $50,000 instrument that is deployed in hatcheries, largely in the US, and allows them to monitor their incoming seawater and understand what it looks like on a day-to-day, notice if there's perhaps upwelling that could be detrimental to some of their shellfish in the hatchery, and just have that really technical perspective. But it's a little complicated to use. They have weekly support meetings for all of their different researchers that have a Berkolator, and it's quite technical. It's very impressive. But my supervisor is working with Dr. Hales and challenged him to try to make something that's a little bit more accessible, both in price and in usability. She wanted something that was low cost, something that researchers around the globe could purchase. It isn't $50,000. The price point we're working at now is around $1,500, and that includes Burke's time in assembling them. So we're hoping to get to a pathway where they're more cheaply assembled, because he is an expert and it's expensive, rightly so. And something that we can also, is a price point that we can purchase ourselves, or create ourselves and then donate to some of our partners too. Something that's portable and rugged, something that can wander around a hatchery environment, get splashed on, isn't like a super expensive piece of equipment that is very delicate, something that can go out in the field and be used in a field environment, whether it's on the shore or on a small vessel, something that's accessible. So it doesn't require a lot of technical knowledge or technical training to use. We try to create something that's an all-in-one system with a little bit of training, and a guide that we've been working on is something that can be easily picked up in an afternoon, and researchers, or hatchery workers don't necessarily need carbonate chemistry knowledge. It'll give them a good enough value for their purposes. And then we are looking to meet weather quality standards as defined by the Global Ocean Acidification Observing Network for this sorts of quality levels with the PCO2 So we provide guidance for doing those sorts of calibrations and pieces to get it to that level. But how it works basically is it's this handheld box, and it contains a pump that circles air through an equilibrator, which I'll show you on the next slide. And so that equilibrates the air moving through this box with the CO2 dissolved in the seawater. That air is then carried through an infrared analyzer, and through the chip on board, it outputs the PCO2, the dissolved carbon dioxide reading, right on the screen there, which users can write down. This infrared analyzer can also talk to a program called GasLab. So when the PCO2 is plugged into a USB to a computer, you can see real-time readings right on the screen and do some advanced calibration through that. So this is Burke using the PCO2 in a beach in Seward, Alaska, where there's clams living in this habitat. So he's used a filter to filter the water first, and is now measuring the dissolved carbon dioxide in the water to get a sense of what those adult clams might be experiencing in their natural habitat. But he's using our bottle equilibrator. So a user can collect a bottle sample however they normally would, whether that's taking a dip out of a tank in a hatchery very carefully, or using a water sampler, and then connect it to the PCO2 and get a really quick reading. We're also working on a floating equilibrator, so something that will sit on the surface of a large hatchery tank or on a near-shore coastal environment and equilibrate the seawater in that way for more spatial sampling. The main use case, as I sort of hinted at, is working with hatcheries for using the PCO2 first to monitor their incoming seawater, and then to buffer that seawater as needed. The Aleutic Fried Marine Institute, which is based in Seward, Alaska, has been a really helpful testing partner for this process for raising the aragonite saturation state for the shellfish in their hatchery to around a value of 4 or so, using carbonate reagents and hydrochloric acid. So right now, the formula that Burke has formulated for this recipe for buffering the seawater is using lab-grade reagents, sodium bicarbonate, hydrochloric acid, and sodium carbonate as well. But it could be such that someone can go to a feed store and pick up a bag of soda ash and baking soda and some hydrochloric acid from somewhere and get good enough results with our calculator. You might imagine some of our partners in remote areas don't have access to lab-grade reagents, but instead could get a high enough value to make the shellfish happy, maybe not get exactly to 3.54 of aragonite saturation, but high enough that they could buffer their incoming seawater. Those of you who are familiar with carbonate chemistry know that you need a second parameter to calculate other bits of the carbonate chemistry system, in addition to the temperature and salinity. For our purposes, an estimation of total alkalinity from salinity measurements is probably good enough. Researchers could use some of these curves that are developed on a global scale. You can see there's some little differences in some of these different ocean basins and areas. So if a team is really interested in refining their relationship, they might invest in sending off 50 bottle samples or so to a laboratory that can help them develop a local curve. This is probably really important also for hatcheries that are near sources of freshwater influence. But again, our goal is good enough or shellfish-ant quality, not necessarily the highest quality data. So finding these sorts of workarounds to make sure it's feasible for hatcheries is something that we've been talking a lot with Burke and other experts on. So in practice, once a user has their reading from the PCO2 to go and a second parameter either directly measured or estimated, they can put it on the calculator that's included with the PCO2 to go. Right now, this is in LabVIEW, but we're going to be working hopefully soon with a contractor to convert it to something that's a little bit more open source. So a user can select the size of their tank that they're going to be buffering, the goal for the aragonite saturation state, depending on the organisms or the life stage that they're working with, and then selecting a PCO2 value that will be stable with that tank. Not necessarily the dissolved carbon dioxide value of the water that's coming in, but something that takes into account the fact that this hatchery tank is going to be fluctuating with its environment over a couple of days, right? If there's workers in there breathing out CO2, that value is going to be going up. So they can take a measurement of the air with the PCO2 to go, get a sense of what that value looks like, and then target that dissolved carbon dioxide value when they're doing these calculations. Once all of that's entered, it calculates the amount of reagents to add to the tank. They can carefully add that in to avoid precipitation. And then that will create stable conditions with a high aragonite or high saturation state, whether it's aragonite, calcite, et cetera, whatever you're targeting, until the water is changed again. Really excited about this. We've been working on getting even more feedback for use of the PCO2 to go with some of our target users. In December, Burke and I traveled down to Ensenada, and we partnered with Dr. Martin Hernandez-Ayon, his lab at UABC Ensenada, as well as Dr. Jeremy Bauer and Rodrigo Baez of CSACE. We invited multiple fisheries collaboratives from Baja California and Baja California Sur who are working with abelian oysters in aquaculturing them to go through a test run of using the PCO2 to go, see how it can monitor seawater in a hatchery, and then doing some practices actually making the buffering solution and applying that in hatcheries. So we're continuing to get feedback from them, understand if it's working with our targeted users, if it's feasible, if it's understandable for those who are maybe not carbonate chemistry experts, but are experts instead in the life of young shellfish. We have a couple PCO2 to go units still in the region. Martin just told me that there's one right now at a commercial oyster facility in the Ensenada area, and then they plan to send it back down to some of the oyster hatcheries in the near future. We're looking forward to getting feedback from them. In terms of next steps, we're continuing to work on manuals and guides to support the use of the PCO2 to go, not only for this good enough shellfish-ant quality, but for users who are interested in getting some higher quality data out of it. What are sort of the calibration steps that you need to take to be able to use it as a tool for use in environments that maybe is too challenging right now, or to collect more data than is feasible through bottle samples. And then excitingly, we just received funding from NOAA IUS through their Technology Readiness Program to increase the that we're doing on making the PCO2 to go more readily available and exploring manufacturing options. We're also glad to be working with Synchro, which is sort of a test bed in Monterey Bay. So they're going to be purchasing a couple and sending them out to different users to compare the usability, to understand what are some of maybe some components that we can change out or make more robust, just to have more in-depth sampling and experimentation with that. But this project with IUS will also enable us to explore a different use case, which is evaluating the impact of sargassum inundation in the Caribbean. So users along the coast who are inundated with large amounts of this algae can understand if it's having an impact on the water quality and make decisions about removal of those mats of algae if it's reaching such a level that it's impacting like their coral reef or mangrove ecosystems. So lastly, I want to talk about one thing we are working on now, which is the emerging field of marine carbon dioxide removal and ensuring that this is growing in an equitable way and we're not repeating some of the missteps that other fields have made along the way as they're working in the sort of technology space or places where there are large investments that maybe aren't made in the best way possible. But we anticipate having some funding over the next couple of years to try to create a more diverse network of scientists around the globe who are engaging in this conversation with the community and can participate in review and implementation of a couple different marine carbon dioxide removal approaches. So that will be done in a couple of different ways. We are looking to gather expertise, so experts like those of you in the room who may be working on some of these approaches for marine carbon dioxide removal. We have some time in there to support the time of these experts. We're also looking to convene dialogues to specifically focus on some of the ethical and legal considerations for marine carbon dioxide removal, to ensure that, for example, companies aren't going to places where perhaps there are questionable guidelines for operating in coastal waters and perhaps exploiting we've seen for other emerging technologies. But we want to make sure that researchers in these countries have the technical knowledge to be able to evaluate proposals that are coming to their governments for conducting marine carbon dioxide removal. So to do that, we're going to be focusing on some online training modules, of course, engaging experts there to produce the material for those asynchronous pieces that are can be deployed in lots of different places, and then really focusing on some experts in developing practical training or inviting everyone together and sort of talking about these different approaches too. So if anyone, again, is interested in talking more about that, I'd be super happy and keep you in the loop as we're just sort of developing this line of our work. With that, I will say thank you so much for your time. I really appreciate the invitation. I've really enjoyed talking with those of you that I've had the chance to talk with today, and hopefully we'll talk with some more after our here in the auditorium. Thank you.
Okay, great. Thank you so much for a wonderful talk. We have about 10 minutes for questions, so I'll open it up to our in-person audience first. Any questions? All right, Fran. Here I come. Get my steps in.
Hi, Caitlin. Thank you for a great talk. I have two questions. One is perhaps a bit silly, and the other one is less silly. I'll start with the one first. With the mini Berkolator, how many people have had issues taking that on airplanes?
That's a really good question. We haven't done that yet, but I will say I had to bring some to Mexico with me. And we definitely chose a route where we didn't think we would be, like I didn't walk across the border where you're more inspected. We drove where they tend not to stop you, because I was a little bit worried about having that box with all the wires, which is probably what you're thinking.
Yes. Yeah.
Yeah, it's a little sketchy looking, but try to explain it's for science, right? I'm sure TSA, customs always see weird things coming back in and out.
Yeah, I feel like that's something that scientists are particularly, when you bring a piece of scientific equipment on a plane or something, it's always fun to explain. Thank you. My second question is, how do you go about finding these scientists that are not in these global north or quote unquote first world countries to collaborate with and share this technology with? Do they approach you? Do you approach them? Some sort of mixture?
That's such an important question. Make sure that we're actually reaching, our target audience. I think our program has developed a lot of momentum, so we have a lot of partners in different areas. When we're working in new geographies, we make sure that we are they're listening really closely, attending local conferences and talking to scientists there. In some cases, we're hiring local coordinators who have connections with lots of the organizations on the ground and researchers to have those sorts of conversations and make sure that we're not duplicating the work, that we're actually meeting gaps, that we're learning new gaps, we're learning about potential issues, with deploying technology that we consider, to make sure that when we're sending things, it's not just going to go and sit in a shed because no one knows how to use it, but there's no one there to use it. That actually happens sometimes. There's a whole lot of expensive scientific equipment that's in like a little like storage closet in some of these places. Oftentimes, we don't have funding for all the research we want to do. I get emails in my inbox almost weekly from researchers that all of them I know, or I've met them at scientific conferences, that are asking for support, and we don't have the funding to do that. We try to keep them in mind when we are able to work in new geographies with new pots of funding that come in. I don't know if I mentioned this, but we're a community foundation. We have to raise every dollar that we spend. So it's a lot of working with partners. We have a whole development team, et cetera, to keep things going. But we're grateful for the support of our government partners, our private foundations, private funders that keep this work going. And we try to express those needs that we hear from the researchers to move into these new areas and ensure that we're addressing some of those salient needs.
Thank you.
Great, thank you for a wonderful talk. I always read all of the COP recommendations, and to see that there's groups really working to make those, come to fruition is really fabulous. And your work down in Baja reminds me of some of the work they're doing measuring oxygen levels in the oceans and working with things like mini dots. And I'm wondering if your program is going to expand into that area, because I know that Baja has experienced some very severe low oxygen events that have killed lots of marine life. So they're very interested in that, and other places around the world. I'm just using that as an example.
I think that's an incredibly important issue too. I remember when I was in graduate school, I felt like the deoxygenation field would be like the next oceanification field in terms of growth. Mm-hmm. And you do sort of see like the international networks that have developed around that are similar to the Global Oceanification Observing Network. I think that's really nice to see. Our program hasn't entered into that area yet for one reason or another. We tangentially have some work there. Our kit that we customized for the research team in the Philippines that I'm working on right now, they already had some of the lab equipment for doing oceanification research. So we're sending them the RBR Solo DO sensor so they can actually use that in concert with your oceanification research. And our work with DFO on the Gemina box, the eutrophication kit, I actually just got a quote for those mini dots the other day because I think that's probably going to be our go-to sensor. So when possible, we try to ensure that researchers can, study not just one parameter. The nice thing about oceanification is that it enables them to also take those temperature measurements, those salinity measurements too, and get some more like of the baseline essential ocean variables. But again, when possible, we try to find ways to build in other parameters and help them get a more holistic understanding of what the ocean conditions look like for whatever research question that they have.
Other questions? I can ask a question. I'll check the chat. So Caitlin, you know very well that even with, better than weather quality carbonate system measurements, that there's still QA/QC issues across different labs, particularly with spectrophotometric techniques. And so I was wondering, aside from the internal lab best practices and QA/QC support, are there additional layers of data validation and inner lab or inner go-on-box comparisons?
I think that's something we are working to improve upon. If I hinted this, the researchers that we provide kits to are super great at going out and doing the monitoring. It tends to be that back-end data analysis side where things get a little bit more clogged up. I think that can happen for a number of reasons, right? They may not have the best intuitive sense of what reasonable values may look like in their environment, right? If they haven't been, like total alkalinity, like what is that value and how does that relate to what they're used to? So part of our guides is providing some information on better assessing their data. But then we've been working on partnering our kit recipients with mentors, so encouraging them to sign up for the Global Oceanification Observing Network's peer-to-peer program and getting maps with an expert so they can actually share their data and go and do that back and forth comparison. A new model, which I haven't really talked about much, is working not just sending kits and sort of creating a disparate network of researchers around the globe, but creating a hub or a center. So we've been able to do that in Fiji that's supporting all of the work in the Pacific Islands. So we've provided funding to the staff there and a lot of training for a couple different members of their team to be able to assess those data questions and be able to coach the scientists around in these different countries on what data are coming out. Is it reasonable? What sort of cleanup processes that they could do? And we're looking at replicating that model in the Gulf of Guinea with our investment there over the next couple of years. So it's a really important question. I think with the whole field, we're sort of working on this issue of QA, QC, and making sure that we're getting good data out.
Awesome, thank you. Just gonna creep online here. All right. Oh,
I had a question about how these data are compiled and then from across the world put in together in one report and where they go after that. It's really great that these data can be collected globally, but then after they are collected, where does it go from there?
That's a really good question. It's probably a better question for the Intergovernmental Oceanographic Commission, which does all that compilation. What it looks like on the front end, though, is they've put together a nice metadata and data template. So they have a spreadsheet that's available. You can search it online and take a look at it. It asks for the information, the salient information of the data that are collected, right? Like where's the location, tide, time, all those bits and pieces, ensuring that you have your salinity and your temperature data that are going on with the measurements. There's some flags, in there. They do some collation as well to ensure if it's meeting these different standards that they've defined. But then it does just kind of go into this database. And I think they're thinking about, ways that we can get a better understanding of the progression of oceanification through more data around the globe. But I don't know if they've fully gotten to that part yet. I think they're really looking to increase reporting first. As I mentioned, it's just 35 countries in just a few spots. And so their 2 staff members are heavily focused on trying to build up the number of folks that are submitting. You might even have noticed in the map of the United States, there's only just a couple of dots, even though there's researchers all over the coastline that are doing these sorts of measurements and could contribute. It does have to go through a national focal point. I think that's especially important in countries like the US. I imagine that's the oceanification program at NOAA. But even in a country like ours, there's some barriers to getting those data out. Researchers that we work with don't tend to publish. That's not necessarily the goals of their government ministries. If they're at a university, yes, that's certainly encouraged, and we have some kit users. We have a really great partner in South Africa who did her whole PhD with the kit, and she now is a postdoc, and she's now a professor actually and still using it. So she's publishing regularly with the data that she's collecting. But most researchers are thinking about it in sort of like the applied context. So the end goal isn't that publication, they're really getting the data out, but being able to talk to the community about some of the changes that they're seeing and putting that into the context of their own traditional knowledge, building in some of the scientific techniques, and thinking about what that looks like in the context of things that they've been doing for time immemorial.
Thank you.
Any other questions? I think I saw a little red. Oh, all right. Let's see. Okay. Question in the chat here. Thinking in the long term, if the baseline standard protocol for carbonate chemistry changes, would there be a redistribution of equipment? I.e., once the kits get sent out, will they be upgraded over time? There's a follow-up too. Do you want the follow-up? Okay. Also, in terms of distribution, is it more based on countries, communities that show more of an interest in data collection, or countries, communities where geographically data is lacking the most?
Oh, that's a good question. So geographically, our interest tends to be where we have funding to work. And typically that funding is based on a specific region, depending on the funder. So that sort of, inherently constrains it in some different cases. But as I mentioned, we do have an open application process for Go On in a Box kits. And so we try to distribute that in as many networks as we can. We work with local partners in the region, like scientific bodies that can distribute calls out in different ways. So we're not just, reaching our same partners we always talk with, but really, researchers in new areas. And so that's one way that we are supporting investment in different places. We wish we could work in new geographies. We've been trying to get some work going in the Arctic, but it's been really hard to find funding for that, for example. In terms of upgrading the kits, We then try to provide spare parts, and in the past have upgraded kits in some different ways, not necessarily with the methodologies that are being used. With the practical best practices I didn't mention, but it's going to be living on a website called PubPub, which is open source, so all of our co-authors can contribute to it. And if something changes or we notice an error, it can be immediately updated, and researchers can comment, like, say if something is confusing, we can do that sort of like back and forth process. But other ways that we've upgraded the kits are including more instrumentation into that. A really important component is a mercury filtration kit, since researchers have to use mercuric chloride to poison their samples and keep them stable for analysis. I took for granted during my PhD research, I could just dump my sample out in a nice little carboy and it like disappeared off somewhere on campus to get handled. And that is not the case for the vast majority of the laboratories that we work at. On small islands or universities don't have that sort of waste management system. So we've instead provided a resin filtration kit. And so they can concentrate their sample in resin. And then we've been working with the Secretariat of the Minamata Convention and the Basel Convention, which are focused on hazardous materials like plastics and mercury, to figure out disposal mechanisms for those resin filters. And that's something where we've gone back and started distributing those filtration kits to some of the earlier kit users that initially didn't have them, and instead have been storing lots of water, every time they're doing measurements in the hopes of one day disposing of it.
All right, well, I think that's all the time we have, but if you have additional questions, we'll be gathering in the South Lounge in about 25 minutes for our new relaxation hour. So please come join us and follow up with Dr. Lauder. And let's go ahead and give her one more thank you.